Okay, let's simulate GLBB now, yeah. Okay, GLBB can be accomplished in two ways. Yeah, the first way is acceleration by the velocity change, and the second way is acceleration by force. Okay, for the first one, yeah, acceleration by velocity change. Remember that every tick we may add the velocity with the acceleration, yeah, v plus equals to a. Yeah, how can we accomplish this every tick? We can simply use the fixed update method. Yeah, refresher, fixed update versus update. Yeah, if you remember, yeah, update is frame rate dependent. Yeah, that means if the frame rate drops, then update will be called less frequently. Yeah, let's say for now our game is 60 frames per second. Yeah, 60 FPS. Then update will be called 60 times per second. Yeah, but if somehow our game's frame rate drops to, let's say, 30 FPS, yeah, that means that update call is only 30 times per second. Yeah, but if the frame rate fluctuates again, yeah, maybe like 9 FPS, also it means that update will be called 90 times per second. Yeah, so it is not really an ideal method to simulate physics. Yeah, that's why Unity gives us a fixed update method. Yeah, the fixed update is frame rate independent. Yes, so that means that regardless of the frame rate, fixed update will be called at a regular interval, that is 60 times per second. That's why fixed update is ideal for physics calculations. Okay, for GLBB scene, let's duplicate the GLB scene. Okay, I will save my GLB scene first, and then I will duplicate my GLB scene and rename it to GLBB. Yeah, I will open my GLBB scene, then I'll delete the my car one. Yeah, this is a duplicate of the first car. Okay, also duplicate the cartridge script, name it car3 DXL. Okay, let's do that. Duplicate this, rename it car3 DXL. Yeah, I cannot attach the cartridge DXL immediately because I have compiler errors. Yeah, so I will edit it instead and rename my class definition here, not car3d but car3d Excel. Yeah, in order to match with the class name. Oh, sorry, file name, not class name. Yeah, class name is here, file name is here. Okay. Now add a new public vector tree named acceleration. I will simply edit here acceleration. Yeah, and then, oh sorry, we are told to add a fixed update method. Yeah, I hope you remember how to add a Unity message. Yeah, if you can't remember the shortcut, then just right click, then choose implement Unity messages. Yeah, okay, the shortcut is Control Shift M. Then, yeah, fixed update is already here. Yeah, I think it is the commonly used method. Yeah, so that's why Visual Studio listed very high in this list. Yeah, fixed update. Okay, and we can simply add the acceleration into our velocity. Rp dot velocity plus equals acceleration. Yeah, that's all. Okay, and then go back to the Unity. Select my car. Yeah, remove this script. Remove component. And then attach the car 3D Excel now. Yeah, until you have two public fields, velocity and acceleration, both in vector 3. Okay, tweak the velocity and acceleration as needed. Let's say the velocity is 0, 0, 0. acceleration as 0, and 0.01. Okay, let's do that. 0.01 and then test it. Yeah, maybe it's not really obvious that the car is accelerating. So if it is not really obvious, you can tweak it. Yeah. For example, let's try z equals to 1 here. What happens? Okay, my car accelerates very quickly. Let's try 0.1 then. Yeah, I think it accelerates, yeah. Compare this car. I will rename it to my car GLBB. Yeah, and I will duplicate, compare it to my car GLB. I will set it over here. Or maybe it's a good idea to use another color, yeah. Let's see. Okay, I have green here. Let's say, yeah, let's move it here. I'll rename it my car GLB, and I will reattach the car 3D. Yeah, this is the GLB version. Give it the value of velocity 1, and for a fair comparison, let's also use or give the velocity of my car GLBB the velocity z value also 1. Yeah, and let's see what happens. Oh, okay, sorry, I forgot to attach a rigid body. Yeah, let's try again. Yeah, as you can see here, the my car GLBB moves faster than my car GLB. So our simulation is correct. Yeah, a note to remember. Yeah, this is important. Unity uses the SI unit, yeah, kilogram, meter, second, Newton, etc. Yeah, if you feel your car accelerates too quickly, yeah, for example, if we try to give the value of acceleration is c equals to 1, yeah, you will see that our car actually moves very quickly. Yeah, if the car accelerates too quickly, then we will need to take into account the time factor. Yeah, let's assume that our acceleration field is in meter per second square. Yeah, if you remember the time dot delta time field, yeah, we have used it several times in the last classes. Yeah, it starts the time elapsed since the last update or fixed update call. Yeah, depending on where we call this field. Okay, so for the correctness of our simulation, let's multiply the acceleration with time dot delta time here. Yeah, in our fixed update, let's multiply our acceleration by time dot delta time. Okay, and let's hit play. Yeah, as you can see here, now my car GLBB accelerates, yeah, in the correct value of acceleration equals to 1 meter per second square. Yeah, previously it's actually 60 meter per second square because we apply, remember fixed update is called 60 times per second. Yeah, if our acceleration is 1, then the velocity is added for each second, it's added 60 times. Yeah, so the unit previously is not really meter per second squared. Yeah, but now after we multiply our acceleration with time dot delta time, yeah, we can make sure that the acceleration unit is in meter per second squared. Okay, the second way of simulating GLBB is by using Newton's law. Yeah, we can also use the relationship of force equal to mass times acceleration. Yeah, to simulate GLBB. Yeah, to apply a force on a rigid body, simply call its add force method with providing the force value. This is also in factor 3 to the method. Okay, if you want to try this, let's spawn another car prefab using a different color. I will use yellow now. Yeah, I will move it over here and then I will name it my car GLBB force. Okay, at the rigid body, turn off the use gravity, and then we will attach a car 3D force script, which we haven't already created. Let's create it. Car 3D force script. In the script, let's create, or actually, let's just duplicate the car 3D Excel, because the content is actually roughly the same, but we need to change some codes later. Force, and let's rename the class name also car 3D force. And for the fixed update method, we are tasked to change the code into rp.addForce, providing force as its parameter or argument. But before we do that, we need to add a new public vector 3 field named force. Okay, so let's change the acceleration into force. Ignoring this line because we will delete it anyway. And use rp.addForce and not factor 3 forward, force. Supply the force field as its argument. It's as simply as that. Okay, in the rigid body.addForce, actually there is a second overload, or a second argument. The second parameter tells Unity which mode to use. But we will talk about this later after we try this one. Let's see. If my car GLBB force is now driven by force of, let's say, 1, will it accelerate? The answer is yes, although it is behind the my car GLBB. Why? We have some reasons now. Let's talk about this. Now, the second parameter tells Unity which mode to use. Because actually Unity provides us with 4 modes. The second parameter is force mode enums. Actually, we have 4 enums here. The first one is force. If you use force mode.force, which is the default value for our add force method, the applied force will be distributed evenly on each consecutive fixed update call, taking mass into account. Acceleration, in the other hand, is like force but ignoring mass. Impulse, apply force only once, which is, as its name says, it is an impulse. And then the velocity change, apply force as changes to velocity. Okay, so this is a comparison table about each force mode enums. If our enum is force mode dot force, the unit is actually kilogram meter per second squared, or Newton. The code equivalent using acceleration, meter per second squared in fixed update, is actually something like this. We can substitute rp.addForce with this line of code. rp.velocity plus equals acceleration times time dot delta time divided by mass. If we use the acceleration enum instead, then the unit is actually in meter per second squared. The code equivalent is rp.velocity plus equals acceleration times time dot delta time, which is very similar with car 3D Excel. over here. Meanwhile, for the impulse, the unit is kilogram meter per second. Yeah, rp dot velocity plus equals acceleration divided by mass. And for the velocity change, the unit is meter per second. Yeah, rp dot velocity plus equals acceleration. Okay, let's try. Let's see if my car GLBB has the velocity of 1001 and acceleration is 001. Yeah, let's try to duplicate it into here. Yeah, and using the force 001, will our car, the yellow car, moves in the same velocity as the blue one? Let's find out. Yeah, if you see closely here, yeah, we can see that both car moves in the same velocity. I will stop it. Then let's see the z value. Yeah, the GLBB force is 98.472. And if you see in the my car GLBB, the z value is also 98.472. Yeah, in this case, our GLBB, our car, moves in the same velocity. Yeah, however, if I change the mass of my car GLBB force into something heavier, let's say the mass of a car is maybe 1 ton or 1000 kilogram. Yeah, now you can see here my car GLBB force is way far behind the my car GLBB. Yeah, because as it is already set here, yeah, if we use the default add force method, yeah, we will use the force mode dot force mode. Yeah, the acceleration is actually divided by mass. Yeah, that is what we meant by applied force will be distributed evenly and taking mass into account. Yeah, however, if I change the force mode, yeah, at force, let's see. Okay, maybe it's a good idea to try this. Yeah, public force modes, and we can simply use the modes over here. Yeah, this way we don't really need to go back and forth from Unity to Visual Studio and so on. Yeah, we can simply just select the modes over here. Okay, if I change the mode into acceleration, let's see what happens. Yeah, now my yellow car moves in the very same velocity as the blue one. Yeah, but if I change this into force, oops, sorry. Yeah, now you can see that the yellow car is far behind the blue one. Yeah, so that's the difference between force and acceleration. Okay, what about impulse? Let's try it. Impulse. Yeah, it's also a different. Yeah, the result. And what about velocity change? Yeah, the velocity change has the same result as we tried previously with our car 3D Excel, but without multiplying the acceleration with time dot delta time. Yeah. So in the velocity mode, yeah, Unity will simply add this force or regard this force as an addition to the rp dot velocity current value. Yeah, that's why if I change my mode into velocity change, Now my yellow car moves very fast. Okay, so that's about the force mode enums we can use in our rp.addForce method. Okay, now for some exercise. Yeah, duplicate the GLBB scene, rename it as exercise, and then using whichever approach to GLBB, accelerate your car by pressing W. Yeah, and then please limit your car speed. Yeah, use factor 3.magnitude field to determine its current speed. Yeah, acceleration and speed limit can be input from the Unity editor. Yeah, I don't think we have already talked about how we can use some or detect some input. So I will teach you about this point. Yeah. So let's do the first and second pilot point, and then for the third and the fourth one, you can try it by yourself. Yeah. Okay, let's do that. I will save my GLBB scene and then duplicate it, rename as exercise 1. Yeah, and then using whichever approach to GLBB, accelerate your car by pressing W. Okay, I will use the acceleration approach, yeah, over here. And then it is told that using whichever approach to GLBB, accelerate your car by pressing W. So we must detect in the fixed update method, yeah, if the player presses W or not. Okay, for detecting W, or here, it is actually a movement, yeah. If you play enough games, you will know that W and S is a movement in the forward or backward fashion, and then A and T in the horizontal axis. Yeah, W and S in vertical axis. Yeah, that's why for this task, we can use a special method. Yeah, we can check if input.get axis and the name is vertical. Yeah, and then we can compare it not equals to 0. Yeah, the input.get axis will return 0 if no movement axis is pressed. Yeah, in this case W or S, or for the vertical axis. Yeah, for the horizontal axis, if uh, neither A or D is pressed, then it will return 0. Yeah, however, if the positive button is pressed, which is W for the vertical axis and D for the horizontal axis, it will return 1. Also, if a negative button is pressed, there is S in the vertical axis and A in the horizontal axis, the input.getAxis method will return -1. Yeah, so yeah, instead of checking it by using if, we can also multiply this acceleration value by input.getAxis, which is vertical. Yeah, be very careful with the axis name here. You must type it correctly. Yeah, vertical, vertical with a capital V. Yeah, likewise, if you want to use the horizontal axis, you must type it horizontal with a capital H. Yeah, remember this, or your input dot get axis will always return 0 if your axis name is incorrect. Yeah, if you wonder how I know the name of the axis, horizontal and vertical, Yeah, I can take a look at the project settings here, and then I have input manager. Yeah, we have some axis here. If I expand this, I will get some values. Yeah. Okay, here we have horizontal and vertical. Yeah, this is actually all the virtual buttons Unity has provided for us to detect user input. Yeah, I will teach you later about the other virtual input as necessary later. Yeah, for now we only need to know about the axis, which is horizontal and vertical axis. Yeah, if I open this horizontal axis, the name is horizontal, then the negative button is left, positive button is right. Yeah, or alternatively, the negative button is A and positive button is D. Yeah, it means that if we want to detect the movement in the horizontal axis, yeah, pressing left or A, the negative button, will result in -1. Pressing right or D, which are the positive buttons, will result in input.getAxis returns 1. Yeah. So there is a negative button as well as the positive button. Okay, let's see. Let's save this. Yeah, and then I will let's focus on the blue car, yeah, because the only modified car or the modified script for the exercise is the car 3D Excel. Yeah, and I will set the initial velocity to 0 first. Yeah, as expected, my blue car does not move, but if I press W, it will move. Yeah, although if you feel that the acceleration is very, very small, then you can always increase it. Yeah. So for example, let me multiply it by 10. Yeah, although I suspect this will make my car moves very quickly, or not really. Yeah, like that. If you want, you can also press S to be for your car to move backward. Yeah, W to move forward and S to move backward. Okay, that's how you detect the user input. Yeah, accelerate your car by pressing W. Yeah, for the other 2 points, I will leave it to you for exercise. Yeah, please do it yourself. If you have any questions, you can always ask me in the Hangouts group chat as usual. Okay. Okay. Now, for this exercise, yeah, your car will disappear from the scene or game panel very quickly. Yeah, you can always try to move the main camera to become the child of your car. Let's try that. Yeah, I will move my main camera as a child into my car GLBB. Yeah, just ignore everything else. Yeah, check that the main camera is now attached to the my car GLBB. Yeah, and then reset everything to 0 for the main camera. Yeah, reset everything to 0, 0, 0. The rotation is also 0, and then change the position to y equals maybe 1. Okay, now we are inside the car, or let's use the 0.886 here provided. Okay, now, however, if you try to move your car, yeah, you will feel that our car doesn't move. Actually, it moves, as you can see in the scene panel. Yeah, if I try to, yeah, actually it moves very quickly, but because the camera also moves with our blue car. Yeah, that's why it creates the illusion that our car does not move in the game panel. Okay, so if you want to test this movement, yeah, please attach the provided tree generator script, yeah, to add some generator trees to the scene. Okay, I will search my tree generator script. Let's see, where is it? Yeah, this one. I have tree generators.cs. I will import it to my scripts folder of my Unity project. And then I will attach it to my car GLBB. Oh, okay, it's still compiling. Okay, attach, are you ready? Not yet. Okay, let's wait a little while. Yeah, the tree generator will generate some trees. Yeah, although it's only a cylinder. Yeah, not really a tree, but you can assume it as trees. Yeah, this will help us sense the car speed during testing. Okay, are you ready? Oh, sorry, because I am still in play mode. Let me stop my play mode and then attach the tree generator. Yeah, and tag the car as player. I will hide these two cars first. Yeah, they are no longer needed for now. And let's run it. Yeah, here you can see that you have already some trees in the form of a cylinder. Yeah, and then you can always move your car. Yeah, although in some point you will run out of trees. Yeah, if you want, you can increase the number of trees. Yeah, and you can also modify the tree distance. So let's say I want to I want my trees to be separated in 10 units or 10 meters, and I want the number of tree is 500. Yeah, so I have a 5 kilometer long of trees. Yeah, and then you can see in the game panel. Yeah, if you think that your vision is not really good enough, you can always modify the position of the main camera. Yeah, I think the provided value is already the best here. 0.9 maybe, not really. 0.86. Yeah, I think it's the best value. Yeah, and of course, you can always modify the tree generator script. Yeah, if you want, you can always modify this script. Yeah. So, for example, if the trees is too narrow, yeah, you want for your trees to be separated even further. Yeah, you can increase the x position. Yeah, here it is +5 by default. Let me try if I spread them by 20 units. Something like this. Yeah, if you feel that the cylinder is not high enough, then you can scale it in the, let's see, I think z-axis or y-axis. Yeah, p.transform dot local scale equals to new factor 3 1 maybe 3, 1. Okay, I will duplicate it over here, and let's see if my tree is taller than before. Yeah, it is taller. So now I can clearly sense the car's movement in my game panel. Yeah, and obviously I haven't started the third and fourth point of the exercise. So if I press W, my car will accelerate indefinitely. Yeah, I haven't implemented the speed limit. Yeah, and the acceleration and speed limit can be put from the Unity editor. It's already here. That's fine. Yeah, or if you want, you can always use the user interface. Yeah, I'll leave the exercise for you to complete on your own. Okay. Now we will try to simulate the freefall 3D. Yeah, I don't think I can separate this topic into a new video because it is very simple. Yeah, just simply turn on the use gravity property of your rigid body. Yeah, so now I will tick the use gravity in the rigid body, and your car will fall down. Yeah, that's all. So freefall motion is the easiest to implement in Unity. Now, what about the projectile motion? Yeah, it is the combination of GLP and GLBB, if you remember. Yeah, GLBB in the y-axis and GLB in the x-axis. Yeah, how to accomplish this in 3D world? Yeah, let's try it in the next video.